Hi everyone, welcome back. The third video lecture. I think it's the last video lecture on introduction to the ferrous alloys. As I said, this is only the informative video. From this video, you will get at least of 2 to 3 gate questions in the material science and engineering or metallurgy paper, or else in the mechanical paper, that too in the material science section. Okay, so we are now we have completed the steel classification, that too three main classification: low carbon, medium carbon and the high carbon. Classification, as well as the third is stainless steel. We have completed its introduction to microstructure, its application and the various mechanical property, and how they behave by addition of alloying elements. Okay, now we are jumping into the next part of iron carbon phase diagram, that is cast iron. So small thing I will draw here. So up to here it is steel is there, right? As I explained in the previous slide, up to here it is steel is there. So after this one, cast iron. Is present. So after the 2% of this one, 2% of carbon, it's a next class of an iron where it will be very important, plays a very important role in the ferrous alloys. Here in the cast iron, the carbon contains above 2.58%. Commonly we will use from 3.3 to 4.5 weight%. So as we said in the previous section, the alpha ferrite and the pearlite is present in the steel. It is in the form of cementite, but in the cast iron it is in the form of alpha ferrite and the graphite. The cementite will dissociate, that is Fe3C will dissociate, will form plus alpha ferrite plus graphite. It is here the carbon is present in the form of graphite. Okay. The formation of a graphite will be promoted in the presence of a silicon. At most we are adding of 1 weight% of a silicon to enhance the formation of the graphite, and the cooling rate will also affect, that is a slow cooling will favors the formation of the graphite, that it helps to dissociate into the alpha ferrite and the graphite. So it is the carbon present here is in the form of the graphite, as I mentioned in the next point. And there is a classification present for the cast iron. Different cast irons are present. First of all, grey iron. I will explain each and every type of an cast iron. Nodular iron and white iron, white malleable iron and the compact iron. Compacted graphite we have present. This is a small classification of a cast iron. So this classification can be obtained by changing the carbon composition and plus heat treatment. Heat treatment process will changes the microstructures. In terms of, it will changes the mechanical properties. Hence, they are different forms. They will form a different form of a cast iron. In our mind, one small question will arise. That is, we have steel which is having a low carbon and it's having a different mechanical properties which can satisfy all the applications, right? So why we need to study this cast iron? So what is the main reason for this one? The reason is processing cost. The processing cost of cast iron CI is very low compared to steel. Why it is having a low processing cost? Because the cast iron melting point is about 150 to 1300, whereas for the steel we have about 1500 is a melting point. So due to this change in the temperature, the processing has been reduced compared to that of the steel. So next class of gray iron. So next class of a cast iron is gray iron. Here the carbon concentration varies from 2.5 to 4 weight% and the silicon is 1 to 3%. Here, as I said, the silicon will enhance the formation of the graphites. The microstructure is shown in this picture consisting of flakes of graphite. These are the flakes of graphite in the matrix of surrounded by alpha ferrite. This is alpha ferrite. So these flakes are like this, and this is alpha ferrite and this is graphite. These pointed edges acts as a stress concentrated area. This due to the structure of this graphite, this gray iron are mechanically comparatively weak and they are brittle in the tension property. When we apply the force in the form of a tension, these points pinpointed edges of the graphite will act as stress concentrated area. So they are very good at compression force. The strength and ductility are much higher under the compression load. And hence, due to this unique property, they are being used in the damping of a vibrational energy in the compression of in comparison of the steel. Hence, the base of the heavy structural materials or the equipments are made up of cast irons, grey cast iron, which absorbs the more amount of the damping. One good example is the lathe machine that have been used in the workshops. The basis of the lathe machines are made up of a grey iron. Yeah, just mention 2 or 3 examples in the comment box section where the grey cast iron has a damping material. And example are UNS number is F10004, composition is 3.4% of an carbon and 2.5% of silicon and 0.7% of manganese. And application is used in the miscellaneous soft iron castings in which strength is not primary consideration. Okay, the next application is example is 1 F1 0008. The composition is 3 to 3.3 weight% of a carbon and 2% of a silicon and 0.8% of a manganese. The application is diesel engine, castings, liners, cylinder linings of the cylinders and the pistons. Etc. Okay, this is the application of the grey cast iron. As I said from the previous video lecture, addition of any other alloying elements can alter the microstructure. So altering the microstructure indirectly will affect the mechanical properties. The mechanical properties, if they are changing, then their application is also changing in the day-to-day life. Similarly happens with a ductile iron. As we said, the grey cast iron is a flakes. The graphite is present in the form of the flakes. So the scientists or the metallurgist has thought that these flakes are being converted into nodular or circular form, which is having a less stress concentrated area. So adding of manganese and the cerium to the grey cast iron before the casting process will form a differently microstructures. And it will form directly will affect the mechanical properties, as I said previously. These graphite flakes are converted into form of nodular or the spherical like particles. Hence, this ductile iron is also called as a nodular iron or the ductile iron. This is the GATE 2003 question. So which one of this is having more ductility? First one grey iron, second one is cast iron, third one is nodular iron, fourth one is second is nodular iron, third one is a ductile iron, fourth one is both 2 and 3. So this is the GATE question. So we have to remember the other names of the alloys also. So it will help you for answering the questions. So microstructure will looks like this. I am writing 2 microstructure here. I will explain. So what's the reason behind this one? So this is nodular iron the spherical form of an iron cementite, graphite, is surrounded by alpha ferrite. Here it is perlite, surrounded to the this nodular form of the graphite. Okay, the matrix will changes, but the graphite form is remains same. Due to this nodular, the ductile iron will have the tensile strength of 380 to 480 megapascal, and the ductility will be varies from 10 to 20%. Due to this, it has a more application in the pump bodies that been used in the agricultural and other industries in areas, and the crankshaft, gears, and other automotive parts, and the machine components are made up of this ductile iron. Okay, the next form of a cast iron is white white iron and the malleable iron. So this white iron, how we will obtain? The first condition is it should contain low silicon, and second is fast rate of cooling, will results in the form of will results is the cementite will remains most of the cementite will remains in the form of cementite, and the some part is converted into graphite. Due to this, it has different mechanical properties. And why it is called as a white iron? The fracture surfaces are appears to be as a white, hence they are called as a white cast iron. So when we are heat treating this one, at about 800 to 900 degrees Celsius for prolonged duration of time, that is long duration of time, will result in the formation of the malleable iron. This cementite will decompose, will form a graphite, results in the clusters of the graphites are present in the ferrite or the perlitic regions. And they are called as a malleable iron. And the applications are flanges, pipe fittings, wall parts of a rail roads. Okay. The overall summary of a cast iron is depicted in this graph, in this picture. First of all, hypoelectrode alloy, that's consisting of low carbon in the cast iron, that is 2.5 to 4%. By doing with the help of this one, with by changing the rate of cooling, we can get the different type of alloys. First of all, if we do a rapid cooling, we will get a white cast iron. As I said, these are in the form of cementite. This is perlitic, and this is cementite. When we are doing a heat treatment, about 30 hours for prolonged duration, the 30 hours for 700 to 800 degrees Celsius. By fast cooling, we will get a perlitic malleable, and for slow cooling, we will get a ferritic malleable. This is a one class of a cast iron. Again, if you do a moderate cooling rate of cooling, for the hypoducted steel, we'll get a perlite grey cast iron, and if you do a slow cooling, we'll get a ferritic grey cast iron. So for example, these flakes, so this is a unique structure. The flakes, if you see the flakes inside the microstructure, then it is a grey cast iron. And again, if you want to differentiate between perlitic and the ferritic, if it is slow cooling, ferrite we will get. If we get the little bit faster, then we will get a perlitic structure. One more class is by adding in a magnesium or a cerium, we'll get a different kind of a microstructure. That is, these flakes will convert into nodular form. Okay, these are a spherical form. These are not a spherical. Remember, this malleable are, these are graphite. Yeah, correct. But they are not in a nodular form. But here the graphites in nodular form, that is a spherical form. Here if you do a moderate cooling, perlite will get, for the slow cooling will get ferritic structure with a nodular graphite. This is the summary of a cast iron, and it will fetch minimum of 1 to 2 questions in each branch. Thank you. This is the end of classification of ferrous alloys. Thank you.